right, so it's time to do a binomial now. Now, Dev's sent me this because he's not sure what to do on part D. But for those of you, well, hopefully we're all right with part A, part 2. But let's just do it anyway. So 1 minus x to the minus 1. 1 minus x to the minus 1. So you're going to use the 1 plus nx formula, aren't you? The 1 plus ax to the power n1. 1 plus ax to the power n. Or is it? And that's 1 plus nx plus n minus 1. Blah, 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 blah. So we're going to have, right, 1 plus minus x times minus 1. No, I'm talking plus minus x squared times minus 1 times minus 2, and that's all over 2. Oh, hang on a minute. And that's all over 2. What's up, Georgie?
What can I have for tea?
Go and have a look in the freezer. Okay, and then this minus x all squared is positive x squared. Minus 1 times minus 2 divided by 2. So we're just going to end up with x squared there. So just 1 plus x. Yeah, that's right. 1 plus x squared. Hence or otherwise show that 1 over 3 minus 2x. Right. So 1 over 3 minus 2x is the same as 3 minus 2x to the power minus 1, isn't it? Okay, so then if we take the 3 to the minus 1 outside and divide everything by 3, we get that. Now, 3 to the power minus 1 is just 1 over 3, so a third. And we want to multiply that by, and we're going to replace, everywhere that we've got a minus x here, we're going to replace, oh sorry, everywhere that we've got an x here, we're going to replace that with 2x over 3. Okay, 2x over 3 plus 2x over 3 all squared. Yes, Georgie?
Can I have some chips?
Where do you want me to get chips from?
Freezer.
Yeah, all right then. Pop them in the air fryer. Plus 4x squared over 9. Got 2 parents. Right. Equals third plus 2x over 9 plus 4x squared over 27. So the tricky bit there, now you didn't have to use the logic from the first bit for the second bit there, but what you were basically saying is if you compare 3 minus 2x power minus 1 with 1 minus x power minus 1, the only thing that's different there, once you've divided that by the 3, like that, and you've got the 3 to the minus 1 on the outside, at that point here, the only difference between minus x and minus 2x over 3 is you've got 2/3 of x. Okay, so your signs are the same, which is why you can just replace the x's here with 2x over 3. Okay, if you're not sure about that, ask. Right, where are we up to? So B, part B. Whee! And that's true for small values of x. Right, okay, so for small values of x, right. Obtain the binomial expansion of that up to and including the term in x squared. So 1 over 1 minus x squared. That's the same as 1 minus x to the power minus 2. So when we expand that, it's approximately equal to 1 plus minus x times your minus 2 plus minus x squared times minus 2 times minus 3 all over 2 factorial, which is 2. So that's 1 plus 2x plus 3x squared. Oh God, the dog's starting now. Right. Part C, given that 2x squared, blah, 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 can be written in that form, find the values of A, B and C. Okay, so we've got no chips. What do you want me to do? Find something else.
There's nothing else. Even peas. I don't really want peas.
Georgie, can you wait 2 minutes? Well, that's a lie. Can you wait 5 minutes? Right, okay. Well, you're just going to have to starve, aren't you? What about cereal? Some noodles. You want some noodle things? Right, you'll just have to wait then. I'll be with you in a minute. Okay, and we're told that it can be written in this form here. Now, we don't need to do any algebraic division or anything like that because the powers on the top are smaller than the powers if we multiply all these on the bottom. Right, so we're going to have to do a bit of cross-multiplying here. We want the denominators to be the same on both sides. Okay, so if we multiply that a by that denominator there and that denominator there, you get a times 1 minus x times 1 minus x squared. And we're going to multiply the b by that and that. So we've got plus b times 3 minus 2x times 1 minus x all squared. And then we're going to do exactly the same thing with the c, but we're going to multiply that by that one and that one. And now everything has got the same denominator. So c times 3 minus 2x times 1 minus x. And you might think, God, this is awful. This is a really, really long way of doing it. Well, yes, it is, but that's the way you have to do it. Okay, so that's equal to that over... Shut up, Peanut! Okay, now all this on this side is all over that common denominator of 3 minus 2x times 1 minus x times 1 minus x all squared. Now you can see the denominators aren't the same on both sides. This one here has got an extra 1 minus x in it. And that's really important because that's what we need to cancel out now. Come on in then. Peanut, come on. Come on. Good girl. Okay, so we need to go, because we want those denominators to match each other. Otherwise, we can't make the numerators equal, can we? So let's go through cancelling out now. So let's, what colour pen shall we have? Oh my lord. Okay, so we want to cancel out a 1 minus x in every single term on the top. Okay, so when we cancel, because if we split that fraction up, everything would have that as a denominator. So we've got a 1 minus x there. Let's get rid of that. Let's get rid of one of the 1 minus x's there. So that makes that power 1. And let's get rid of that 1 minus x there and a 1 minus x on the bottom. So we've cancelled out a 1 minus x, a factor, or in other words, taken out a factor of 1 minus x out of every term on the top and every term on the bottom here, and they cancel each other out. So we're left, now our denominators are the same. We've got 3 minus 2x times 1 minus x squared on both sides. So now we can equate the numerators. We can just say those numerators are now equivalent. Okay, so we've got a times 1 minus x squared. Let's expand that. That'll give you 1 minus 2x plus x squared. Okay, let's expand that other bracket now. 3 minus 2x times 1 minus x will give you 3 minus 2x squared minus 5x plus c times 3 minus 2x. What are you doing, Peanut? Right, it's chaos this house. Right, now we equate coefficients. So x squared terms, we've got 2 on this side. We've got an a, if we expand that there, and we've got minus 2b. Equating our x terms, we've got none on this side. We've got minus 2a on that side, there, and we've got minus 5b, and we've got minus 2c. And our coefficient, oh sorry, not our coefficients, our constant terms, so our constants, you've got minus 3 on this side, so they're just the numbers, aren't they? Got minus 3 on this side, a times 1 is just a, 3b, and we've got 3c. And if you wanted to, you could work that out. There's loads of different ways to do it. If anybody's interested in looking at further ways, like further maths people, you can use Gaussian elimination and stuff for that. The rest of us would just use a calculator. We've got 3 unknowns and we've got 3 equations. Okay. So we've got 1a minus 2 b's, sorry, no c's, and that's equal to 2. And then we've got minus 2a's, minus 5b's, minus 2c's, and that's equal to nothing. And then lastly, you've got 1a of 3b's and 3c's, that's equal to minus 3. I'm not sure I've got that right. That gives me that a is 30 over 17. B is minus 2 over 17. And C is minus 25 over 17. Now I don't like that 17 on the bottom. So there's another way. I'm just going to check this. I'm just going to pause the video while I go and check it. One moment. How do I pause the video? Okay, I think I've realised where I've gone wrong. Oh, stupid girl. Right, it's... Ow! Stop it. Minus 2x times x up here isn't minus 2x squared. It's plus 2x squared. Duh. Right, so that should be a plus there. Right, okay. So not an issue, not an issue, not an issue. Let's go and put that all back in the calculator. Let's see if I've done it right this time. I'm just going to pause it. 1 minute. Okay, this looks a lot better this time. So now it gives me that, my A is going to be 6. My B is going to be minus 2. And my C is going to be minus 1. Now that looks a lot more realistic. So this goes to show you it's always a good idea just to double check through your working, but it is very hard to find. Right, okay, so that, 5 marks, nice. Hence, find the binomial expansion of this up to and including the term in x squared. So if you compare part C with part D, what we're really doing is finding the binomial expansion of this A plus B plus C over all that there. So, okay, so we have our A, let's go back and write this properly. So we've got A over 3 minus 2x. Right, so we've got 6 over 3 minus 2x. Minus 2, because that's our B, over 1 minus x. Minus C, which is 1. Minus C, sorry. Plus C, which is minus 1, over 1 minus x squared. Okay, now you should recognise this from earlier. Okay, so 1 over 3 minus 2x was approximately equal to that, which we showed here. So 1 over 3 minus 2x, 1 over 3 minus 2x we got was equal to that. Okay, but we haven't got 1 over 3 minus 2x, we've got 6 of them. So we've got 6 of these. So 6. Hang on. So we've got 6 of that minus 2 of our expansion of 1 minus x to the power minus 1, because that's 2 over 1 minus x, which is 2 times 1 minus x to the power 1. And our 1 minus x to the power minus 1, that was what we did right at the start. That was 1 plus x squared. Okay, so we have 2 of them. Oops. Get them in roughly the right place. Okay. And we want to take away 1 minus 1 over 1 minus x squared. Now 1 over 1 minus x squared we've done here. That was part B, I think. Okay, so minus 1 lot of that. Okay, and now we can expand, simplify, and we should